Hello and welcome to this week's episode of Automate It, our weekly podcast where we talk about robots, make some robots up, and talk about fun things in the field. I, of course, am Stefan Soxbacher, CEO and co-founder of Polymath Robotics, and your co-host here at Automate It. And sitting next to me is a gentleman wearing a robot t-shirt. He thinks that when the robots come, they'll image recognize against the logo on the t-shirt, think he's one of them, and he'll get a free pass.
Yeah, have you seen those shirts, the machine learning confusion shirts?
No, I haven't.
Yeah, there's a whole sub-brand of shirts and sweatshirts that attack machine recognition cameras. Yeah, seriously.
Yeah,
they have these like bizarre patterns on them.
Like ones that look like stop signs for Teslas?
No, like they're usually like distorted kind of images of crowds. Mm-hmm. And then you basically become invisible on human tracking cameras. Like you can walk across the frame and it just does not recognize.
And what have you used this hoodie for thus far?
I mean, there's a few versions like this. There's another good one that I like where you put a really, really bright infrared LEDs on a hoodie with a battery pack. And then to any normal person, you don't see anything. But to any nighttime security camera, it's just a halo that completely blinds it.
You know, I remember as a kid reading like a Punisher comic book set in the future, like Punisher 2059 or something. And in one of them, he had some magic piece of code that blocked out his face in a security camera, which like in my like early 20s, I thought of as like, there's no way that would ever be a thing.
Yes.
But functionally, our reliance on ML means that machines are getting trickable again.
Yes. So for anyone in Los Angeles, please do some search on this. I'd recommend the distorted code hoodie, the LED lights, and then face paint. There's also face paint versions that make you a lot harder to recognize, like shadow and highlights.
So this is a surprise show where we're actually just going to talk about how to spoof security stuff, or more realistically, we're going to talk about robots. So this is Automate It. We do this podcast in two sections. First, we play a game where we make up a silly robot, usually by drawing some random cards in an app, but I'm going to cheat this time. And then we're going to talk about some broader subjects in robotics. Silly, what are we going to talk about today?
I think we have two topics on the docket, and we'll see if we can get to both. The first one is Three Laws Robotics.
The Three Laws of Robotics, not to be mistaken with the company named Three Laws, but Arthur C. Clarke or Isaac or Asimov. I'm really good at names. Asimov's proposed rules for robots because I'm rereading some Asimov right now and thought, hey, this might be fun to actually talk about. And then what else are we going to talk about?
And then the other one, if we have time, is theoretically how do you defend against fiber optically controlled drones, like the ones being used in Ukraine right now? Which
will be kind of neat to talk through. And with that, let's start our podcast. I have recently had a problem that I thought of a great robot for. So as you know, in my backyard, I put down a bunch of like kind of small pea gravel to kind of tidy it up and decrease how much area I had to do landscaping over. For my next phase of landscaping, and in my raised beds, I put some plants in and I put some wood chips on top. Now, I have a very rambunctious...
Wait, I have a question, though. Mm-hmm. What milestone is this in your lineup of becoming a slumlord millionaire?
I put the gravel in the backyard, so the backyard counts as livable space.
Right.
So boom, I can add 200 square feet to my favela.
AD.
And then I put the raised beds in, and in the raised beds I want to put a shed that someone has to live in.
Perfect.
I mean, gets to live in for a low price of $2,500 a month.
It's a steal.
Yeah.
You can even steal Wi-Fi too.
Yeah, great. It would be a steal.
It'd be fine.
You think I should be allowed to do it? So my rather rambunctious dog will run into the house, the backyard from a walk, jump up on the wood chips, and spread a bunch of like the small little wood chip debris into my very cute and otherwise tidy looking pea gravel. And it is an absolute pain in the butt to squat down and pick out like gravel, wood chips that look a lot like it could just be dog poop or could be a stone or, there's infinite of these wood chips intermingled.
Have you considered not having a dog?
Yes. Over this particularly, not as much. So I think this actually would be a useful place for a dexterous human hand to serve as a gripper.
Okay. Not like an industrial fan to just blow the wood chips because
No,
they're
because
lighter?
some of the stones are similar weight as some of the bigger wood chips.
All right.
There's an overlap between the two.
Flamethrower?
Could do a flamethrower, but there's something about San Francisco and big fires that like people get weird about.
I mean, serves dual purpose. You can also evict your favela livers if you ever need to.
But like my thought is, so like humanoids, yeah, whatever. But like I not only for like picking out these fine wood chips from stone, I think there's probably a world where having a full dexterous robot arm, robot hands at the end of a gripper, could do things that a current, gripper that like old people use to get things down from high shelves can't quite do.
But do you need all 5 fingers, you think? Because like when you actually pick up stuff, it's really only the 3 main ones. These 2 are more for control of large objects.
Yeah. So
right. So like
it's
3
probably your pointer, your middle, and your thumb.
and your thumb. Exactly. Yeah. Yeah, because your pinky and your ring finger are really for controlling like javelin throws or that sort of thing.
Yeah,
right?
which I do frequently in my backyard. My neighbors hate this one trick.
Is that what you currently use to evict the favela livers? Your javelin throw is great to 5 meters.
They leave quickly. Yeah. But I mean, like, all right, so like, what I think is interesting about this is like just on the realm of feasible. Where the interesting robot problems will show up.
Yeah, I mean, the thing that people kind of forget about our fingers, right, is if you want to do this kind of first principle model of it, it's like, okay, you do 2 fingers with maybe 2 degrees of freedom and the third one with 3 or 4 degrees of freedom, like your thumb, right? But the problem is if you actually look at your hand, your fingers can actually spread apart too. And that's a big part of gripping. Like that's a surprisingly large part of how you grip stuff is how far apart you spread your
because even if
apart.
I think of like, I have these like long thin wood chips sometimes, that might be like 2.5, 3 inches long, but like 3 millimeters wide.
Yeah. So your like 5 degree of freedom problem suddenly becomes a 9 degree of freedom problem.
Yeah. And like my pea gravel is probably, a centimeter in diameter. So there's similar sized obstacles. I mean, some problems I see here is how do I actually grab the wood chips?
Yeah.
How do I differentiate like that I want the wood chips? Now, like if I'm down like on my knees on the ground in the backyard where my dog poops and pees, I can tell the difference between wood chips, stones, and dog poop. But from rather high up, it's not simple.
I mean,
so you probably actually need sensing on this hand.
No. I think if oh, but you're saying the person's actually doing the pickup?
I'm not saying this is a humanoid. I'm saying
this is an arm on
Stefan
the end.
is holding a stick that has a hand at the end, and I put it down on the ground, and it grabs the object that I want, but not the objects that I don't.
Yeah, I think that's gonna be a tougher problem than just putting a vision system on the thing and feeding it a bunch of training data and having it figure out what's the wood chip and what's not the wood chip. Because that would honestly be easier.
Yes,
if you just put a camera on the wrist.
No, I'm thinking of this as a general purpose dexterous gripper.
But even like UI based, right? How are you going to tell it when you're swinging this arm around standing, so at arm's length, literally? How are you going to tell it, I want you to pick up this wood chip and not this stone that's 3 millimeters away from it?
Voice.
No. All I see is Stefan roaming his backyard in his bathrobe.
This is a great, a realistic thing could be, pick up my gripper.
Yeah.
Say out loud, like hold the command button, say out loud, we're going to grab wood chips from the backyard.
Okay.
Or wood chips from the stones. Hold it down and just kind of like wave it around, and the hand gets what the hand gets.
Okay. But then you still need cameras on the wrist for the hand to actually see what it's picking up.
Yeah.
Okay, that's fine. That's fine. So okay.
Like similarly, if I'm in the grocery store and it's like, get the ketchup from the top row. Just go. I get the hand in the area of the ketchup bottle.
Yeah,
or in the area of the wood chip, and the hand just does its own thing.
Does a last little bit.
Like the hands in the Addams Family.
I mean, if you're controlling the wrist as well,
I want sing on a stick.
Yeah, I think if you're controlling the wrist as well, I'd actually simplify it to make the wrist 2 degrees of freedom or 3, right? Rotate up, down, left, right, and then just have a pincer. Right? Because at that point, what you can do is you can use if the robot knows its own shape, it can use the pincer tips to sweep other objects out of the way with just the wrist, with just kind of small adjustments.
But it probably has to give you
feedback.
You probably have to give the human feedback I just swept this out of the way. I just swept this out of the way to the right. Now I want you to swing the whole arm assembly back to the left.
No, I think all the micro control is at the wrist.
Yeah.
Right. And so you're doing the gross positioning, and the wrist is doing all the fine control to actually.
Now, if I was doing all the gross positioning and there's no feedback loop to the hand and that intelligence, how much would that complicate my overall problem?
I think it's the same. So I think you have the camera mounted above the wrist or away from the wrist, and then you're doing kind of visual servoing on your surroundings.
Yeah.
So it doesn't really matter where it is in space. It just knows it's trying to pick up a thing within its field of view.
Yep.
That's no harder, no easier. I mean, assuming you're not swinging the thing around like a madman.
Yeah, like swinging like, I don't know.
At a sedate pace,
Yeah.
I don't think it'll make much of a difference.
And then, so probably then would have to give me some sort of feedback when it has something, like a little vibration or something. And then I chip it up and throw it towards the rest of the wood chips.
There you go.
So, okay, so in this design, we need a dexterous human-handed wrist. A dexterous robot-handed wrist.
A wrist and a claw, let's call it. Yeah, it's probably cheaper.
We need, yeah. So even in our thing where it's like, let's take a piece of a humanoid and make it useful, it's like, we don't actually need the hand.
No.
We just need a claw.
Fundamentally different tools, right?
Yeah. So, and I don't know, maybe if this is supposed to be a universal gripper, maybe I should be able to get like, paper towels from the top shelf. So maybe I actually want a full hand.
I think gripper will do 99% of whatever you want, right?
Okay, so we got a gripper.
Yeah.
We need some sensing. What type of compute would we need for this to be able to run? And how much battery would this have to, like, is this going to be do I need a full like $30,000 ruggedized GPU and 20-pound battery? Like
I mean, I think if you spent some time tuning this thing, you could probably get a small local model running with camera right on board. If you spent the time to compress whatever ML model you're using down and down, quantize it down and down to a reasonable size, you could probably run on like a modern NVIDIA something, right, without too much trouble. Battery life wise, since you're doing a lot of the gross motion and you're holding the thing up, the actual energy needed to do this is fairly small. So you could probably get away, like actually,
especially if the model got efficient enough.
Yeah, you know what? Actually, if you were to build this in your backyard, the best bet would be to buy a 2 or 3 year old cheap cell phone that has on board coprocessors or NPUs, and then run your models on it. You have your camera, you have your processing, you have your batteries. And like most of what you need is there as long as it's reasonably accessible and you don't have to sign your life away to Samsung to get access to the NPU.
So you think this actually is a cell phone plus a couple of extra parts? Like this might be a $2,000 bomb, $1,000 bomb.
I think like this is well within range of a 4th-year design project for a university group, like an undergrad university student of like gripper on a stick. Which is cell phone plus software plus a connector to control some motors. And like off you go. Go grab the ketchup, right? Like fine wood chips it just comes down to dexterity, which is just very painful to do. Like one of the easy hints I always see whenever I see grippers on humanoids, the two things I always ask is are the finger pads soft or hard? And if they're hard, there's no way they're doing real work. Because try to pick up a marker with a pair of salad tongs. Like you'll just fly out of your salad tongs because you need softness. And the other thing is, are the pads actually sensitive? Because if you have sensitive soft pads, then you can pick up extremely complicated objects. If you have hard insensitive pads, really small things becomes really difficult. And the last hint is actually nails.
Really?
Surprisingly, we use our
leverage?
nails a lot. No, it's to pick up thin objects. Pick up a coin or a credit card off a table. Almost always you do a motion where you actually drag your fingernails across the table to pick it up. Because
which
you can't
again
use your
pushes
pads.
back towards this actually maybe should be a hand.
Well,
if I want to be able to pick up a piece of paper from the ground.
Or it's a 2-dimensional grip or it's 1-dimensional gripper with a sharpened tab on the end of it, right? Like you mimic biology, but you don't recreate biology.
So this could be a $2,500 thing.
Yeah. Well within range of an undergrad team doing an assistive technology. Absolutely.
I mean, it seems to me like probably a thing that exists in 20 years.
Yeah. I mean, I think the real challenge actually would be to get it easy enough for humans to use and not awfully heavy to the point where your grandma can't lift it.
20 years.
And yeah, absolutely.
A cell phone on a stick.
Yeah,
20 years.
Yeah.
Yeah.
Right.
Well, we did it again. We accidentally created a company. Now moving on to our actual
wait, what's the name?
Get a grip.
Handshake deal.
Get a grip.ai.
No. 3,000. No, my wife always jokes that we're always happy about handshake deals that we're making. So I think we just call this the handshake deal.
And the 5Gs.
Yeah. There you go.
The 5Gs it is. Good God, girl. Get a grip.
Yeah, that's right.
So I am in between normal book series right now, and started reading some Asimov iRobot short stories. And a thing that I haven't thought about in a while, a thing that I haven't talked about in a while, is the 3 Laws of Robotics.
All right.
And for those of you who are not familiar or don't quite remember them, Isaac Asimov wrote a lot of robot literature, 48 different compendiums of short stories about robots, most frequently referred to as the iRobot series, which have a lot of interesting ideas in it, self-driving cars, humanoids, like all sorts of ideas he was a big pioneer in. With this idea, and these series were written probably 1960, 1985-ish range of time.
Late 50s to early 80s, I think.
Yeah.
If I had to guess.
So there's a lot of hand waving about technology. There's a lot of stuff that is very clearly not how it works. So the story I've been reading seems to hint towards something like LLMs, like making statistical guesses, not just using logic.
My favorite thing anytime you read an Asimov story is everybody's smoking all the time, constantly, every single scene.
Well, the current story I'm reading, the robot has female intuition, which is to say they make guesses.
Great.
Yeah.
Thanks, Asimov.
But the robots are made to be safe because they follow these 3 laws of robotics that are programmed right into their positronic brain. The first law is that the robot may not injure a human being or through an action allow a human to come to harm. The second is that the robot must obey the orders given given by humans, except where such orders would come into conflict with the first law. And the third is that assuming both those 2 laws are followed, the robot should prioritize their own survival. And I think this is an interesting concept as a zoom out from, our normal conversations of, how are LLMs useful for robotics, or what are problems and controls when you go from one way to get around to another. But kind of this naive assumption of why can't you program the 3 laws of robotics into a robot?
Yeah, and when we were discussing this topic, my warning was like, this can descend into philosophy.
Yeah.
Because the first question is just like, if you look at the first law, right? Cannot allow a human come to harm. Okay, how do you define harm? Right.
Well, I mean, I think a lot of the Asimov stories focus on just that.
Yeah, exactly.
Like I suspect the one that I'm reading is going to be, the robot crashes a plane to stop other people from coming into harm. I suspect is my, that is often actually what I think is more interesting than the rewriting an Asimov short story is why can't you just program it that it can't hurt humans?
Well, and that's what I mean, right? Like, the technical challenge of the philosophy question of how do you software define harm?
Yeah.
Right. And it's actually a problem that's come up right now in AI safety research, where when you're trying to develop an AI agent of some kind, and the example they give is like, your grandma is stuck in a burning building.
Yeah.
There's a great little short YouTube video by a channel called Rational Animations, very highly recommended. I'm going to steal the story from them. Your grandma's trapped in a burning building. You tell your magic genie machine, save my grandma. And it says, what do you mean by save? And you say, oh, okay, get my grandma more than 10 meters away from the fire.
Yep.
It's like, great, explodes the house, grandma's ejected out of the building. Okay, get my grandma more than 10 meters without exploding the house. Okay, takes grandma, picks her up, drops her out of the second story window. Right? Yeah. Like the amount of rules you have to program in to define exactly what you want done becomes infinite to the point where you have to understand human society to understand what you're actually trying to do.
Yeah.
So coming back to the harm example, right? Like, how do you define harm? Like, is alcoholism harm? Should
the robot smash this beer out of your hand?
Right. Like, should it come up and just smack the beer out of your hand because like alcohol is not great for you? And how do you even program in this infinite set of rules where in some conditions having a beer is okay, and in other conditions like driving, a beer is not okay?
I mean, I think there's almost within this, there's a assumed omniscience of robots. And given that most of them can't walk into a novel environment, do a somewhat routine but slightly changed task.
I don't even think it's maybe, but I have a different viewpoint on it.
Okay.
I think the difference is that the vast majority of humans are not software developers. Thank Christ.
Okay.
And so when people don't actually have to face the idea of like hard logic on a day-to-day basis. And common sense tells you like, oh, well, I know what harm is. You know what harm is.
Yeah.
Any person you talk to, like you might disagree if alcohol is harmful, but like the broad things everybody agrees on.
Yeah.
But if you're not trained in actual logic, or you don't have to develop software, you don't really understand like, no, that concept is amorphous and extremely multifaceted. And actually breaking that down is very, very difficult.
Yeah, I feel like it's a similar sort of this sort of set of ideas is easily wanted by the types of people who would avoid a Socratic argument about what is the nature of love, or what is art, or what is harm. And like similarly, like those conversations can be fun and very rewarding. It's very hard for them to result in a if A then B equals harm.
Yeah, exactly. And there like in early efforts here, right? Like in early efforts in early machine intelligence, I'm talking like the 70s, 80s, 90s. There was this thought like, okay, I'm going to codify the world's rules. Yes, there's a lot of rules, but there has to be fundamentally a finite set of them.
Yeah.
Right? Like there's not infinite ways to harm someone. So if I just buckle down, hire 10,000 people, we will write every single possible rule as a giant if statement, and off we go. And those efforts invariably failed, not due to a lack of development, not due to a lack of effort, not due to a lack of compute, but fundamentally because you can't break down reality that way.
Yeah.
Right? Like you cannot break down every possible condition because you get just this computational explosion really quickly. But so the modern approach here is, okay, well, we're going to use LLMs. We're just going to throw a ton of training data at them. And like, hopefully out the other end comes a rational understanding of the world that mirrors what a human has. And a lot of the research in AI safety right now is, how do you ensure, assuming that's done, assuming we've done this magic system, how do you ensure that the thing that came out the other end is actually a good model of how humans think? Or does it accurately reflect the training data, but as soon as you're slightly outside of the training data, it breaks down? Or, and this is worst of all, how does it pretend to model how humans think, but actually have a nefarious hidden goal of eliminating humans?
Yeah.
Right? Like that's the main AI safety research right now, is how do you make sure that the thing that came out of this magic box out of the other end is aligned with human interests? Like truly aligned, not just looks like it's aligned.
And part of the problem here is these systems get so large and so complex that
we
have to depend on their evaluation of themselves, and we have to depend on their evaluation of themselves matching anything that looks like reality and not being an independent hallucination.
Yeah.
Let alone a sophisticated attempt at deceit.
Well, yeah, and it's kind of telling that the field is very nascent and very complex because it mixes like computer science and formal logic and philosophy all kind of into this mishmash. The current cutting edge approach, at least what I've read, is basically today we can be relatively sure that ChatGPT is not trying to trick us. Relatively sure, right? Like it's probably like it hallucinates, it does stupid things, but it's too dumb to be actively trying to kill us right now. That's almost for sure. So what we do is every incremental step, every new AI we train, we use the immediately previous generation to help check the next generation. And then when you build the next generation, you use the immediately previous 2 generations to help check the next generation. And you just kind of like build this wall of trust. But like that approach has obvious giant flaws, but we haven't really thought of anything better so far.
Yeah. I mean, coming back to thoughts like the 3 laws. I mean, I think there's baked into an assumption that that a robot knows what a human is.
Right.
Like not even like what is harm.
Yeah, like software wise, again, like here's the thing, right? If I gave you a challenge of given video input from an arbitrarily good camera, right? Like better than human vision, which is not even always the case. Better than human vision, how do you code up detection of human or non-human?
Yeah.
Right. And like there's a ton of now, fairly robust human detectors and techniques, both classical and machine learned. But like all of them are fooled.
But what if someone's wearing that hoodie,
like we were just talking about,
then suddenly we're okay with them being run over.
Right.
Yeah.
Like you can in the vast majority of these human detection algorithms, you can do an attack on them by like just simple stuff that a human would immediately see through. Like think of the game Metal Gear Solid, where Snake puts a box on and just walks around with a box over his head. Like that will defeat the vast majority of human detectors today, like trivially. So again, there's a case of like, how do you even program the detection of this is a human?
I mean, in a way, like going back to your initial statement of this, there's a chance of this devolving into philosophy. Like reading a summary version of the first law of robotics, and inserting the word philosophy for anything that is not necessarily defined. So first reading it and then reading it again. The first law states that a robot may not injure a human being or through inaction allow a human being to come to harm. And let's just cut it off there. So we're subbing in the word philosophy for anything that we could debate, like what is a human, what is harm. Right. The first law states that a philosophy may not a philosophy or through philosophy allow a philosophy to come to philosophy.
Exactly. Like it's completely any one of those things is multiple PhDs worth of effort.
And like in multiple philosophy treatises.
Yeah.
About like what is inaction.
Yeah.
Like, I mean, Heisenberg uncertainty. Is a robot simply existing in a space? If it doesn't do anything, does that count as action or inaction? Could itself be an argument?
Well, yeah. I mean, even like nitty-gritty technical detail, you will always have limited compute. Even as compute gets more and more powerful, there's a limited finite amount of it. So is the computer immediately going to get into a halted state trying to calculate all possible cases where it could lead to harm? Right? Like it walks out onto a street and immediately freezes solid because it's trying to track every single person in the scene and figure out that if it didn't start moving 3.2 seconds earlier, it would have caught the baby that fell out the window.
I think there's an interesting macro point here about that pushback on people who do not deal with formal logic. And that like it is very easy for people to insert rules of don't philosophy the philosophy unless philosophy. Right. It's very easy for regular people to insert that without having downstream consequences of it. And I almost wonder if a useful heuristic might be that any robotics program bound by rules that have too many of these philosophy variables injected are almost doomed to fail. Because like we talked before about like how safe is safe enough.
Yeah.
How philosophy is philosophy enough.
Well, yeah, and I think the reason why stuff like on-road autonomous vehicles have seen some progress beyond like basics is because on-road rules are extremely codified. Yeah. Right. Like for sure you must stop at a stop sign. There's no argument. The reason why
they haven't gone as far is because many of them are under some set of rules of. I think philosophy, and you think philosophy, and let's debate all four of those variables next to each other.
Yeah. Yeah, if the vehicle's following a stop sign that's on a construction vehicle that's driving, obviously you shouldn't stop in that condition. Yeah. Right? But
unless, of course.
Yeah, no, exactly. So you get into this like diminishing returns of here's the 30,000 possibilities of dealing with stop signs that you have to configure.
Or you come to accept non-ideal philosophy states, which people really struggle with.
Yeah.
Like people really struggle with the utilitarian, the not getting stuff side of utilitarianism.
Yeah. I mean, that like the average person never having to program anything means that they are also not comfortable with the concept that safety outcomes are not black and white. It's not like no planes fall out of the sky or all planes fall out of the sky. It's like what is the level of planes fall out of the sky that is still economically viable to fly planes with?
That's. I think this macro of like anywhere where philosophy starts being a variable, is there be dragons.
Yeah.
And like and maybe like as roboticists we should strive to exist in spaces where philosophy variables are easily minimized.
Yeah, well, I mean, structured spaces, right? Again, robots have seen good success in places where it's just do this very simple task, ignore everything else. Yep. Right? All the classic industrial arms that will happily chop a person in half because they can't even see them because that's not part of their sphere of work.
Their rule is just go do this
drive from here to here
over and over.
Exactly.
Yep. And the philosophical constraints are pushed to someone else outside of the ARM developer.
Yeah.
So let's talk about drones. Let's talk about drones being controlled through fiber optic lines.
Yeah. So really quick recap from a non-expert in this space, but somebody who's worked with quadrotors, right? Is early on, quadrotors became, or drones, as some people call them, became a viable weapon in the Ukrainian conflict because of a number of reasons, but one is they're cheap. The consumer-grade electronics to control them was well developed, so you could get FPV goggles on your head, and you can control a quadrotor for about 2 or 3 kilometers, and that was like, buy them on Alibaba, it's there 2 days later, like off you go. You take that, you strap a grenade to it, it's a weapon, it's great.
It's great.
It's great. It's great.
It's effective.
No, sorry. Yeah. To be clear, for a country that did not have a viable defense, it proved extremely effective for a number of reasons. And it's cheap. The thing is, you can deploy 50 of them for the cost of 1 Javelin missile, or 200 of them for the cost.
More than that.
Right, exactly.
I mean, comparing like $100 to $250,000.
Yeah, exactly. Like you could deploy so many. So you could miss 90% of your shots and still be drastically more effective.
Yep. In the military, there's actually become a new term that's come out of the Ukraine War of attritable robots.
Yeah.
Robots that it's completely okay if they're just a one-way thing.
Yeah, if they just immediately fall apart. And that, of course, has been aided by cheap lithium-ion batteries, cheap motors, cheap control systems, and that's all was actually fueled. I think it's probably one of the rare cases where commercial consumer toys influenced military hardware and not the other way around. Now, that phase died off because they realized that you're using radio to control these things. And despite trying to encrypt it and despite trying to be clever with the radio, eventually people started walking around with big backpack-mounted jammers. Yep. And you can see tons of photos of these, of like these big, bulky backpacks with 12 antennas sticking out of them that output, and I think even Anduril builds one, right? That output like a dead zone of about 500 meters around it. And so as soon as the drone enters the zone, all radio communication is, and it just falls out of the sky immediately. And so the immediate next step was now there are these drones, same drones, a little bit bigger to carry a little bit more weight, that have a cylinder on the back that has a spool of about 10 to 30 kilometers of fiber optic line, which is hair thin, right? What's 30 kilometers in American units?
No, 20 miles?
Yeah, 20, let's call it 20 miles, right? Like very, very long distances, right? And again, with this spool, it's relatively lightweight. You don't need a radio anymore. And so your drones can travel a little faster or a little further on the same battery charge. It's been a few years now, so they've been optimizing their battery technology, their motors, their control systems. And so now you're getting drones that are flying 20 miles, right? Which is a huge distance.
Yeah.
And as the drone is flying, it's unspooling this fiber optic line behind it.
Yep.
And you can go online and you can find these videos and photos of fields that are just covered in fiber optic lines. And I saw somebody had even had proposed like, oh, here's a video camera feed of tracking a fiber optic line on the ground to find the operator, because now both sides are using this, of course. And somebody replied back like, try that on this. And the photo was just a field that was just completely covered, like spider webs, just covered in fiber optic lines in every single direction, right? So the question is, how do you defend against this? You can't use jamming, because jamming is irrelevant. You can't use directed energy weapons, like basically directed jamming or directed EMPs, because again, like you can shield these things. It's an optical signal. It's 2-directional. You're feeding video back to the operator and you're feeding commands forward.
How fast do these drones fly?
Very fast.
I mean, like miles per hour.
I mean, as slow as you want, and I would have to guess up to 60 miles an hour.
Okay.
Like fast.
So the string is only over, let's say we know the field they're going to go over.
Yeah.
Like there's a field, we have set up our little like forward observation post. Yeah. And the string is going to go over that.
Yeah. They fly pretty close to ground level, like on purpose, because if they fly above the tree line, it's easier to get them shot down. Yeah. So they'll fly very close.
No, but like we know where the string is going to be.
Okay. In a rough area.
Right. Yeah, like we know in this acre big field or 5 acre large field, the string will go through it at some point.
Right.
At 60 miles an hour, 20-mile trip. Let's say we're at the 5-mile mark or the 10-mile might make it easier.
Sure.
How long will the string be there, assuming it's one way?
I mean, what's that? 6 minutes? 60 miles an hour, or hey, a matter of minutes. Like we're talking about literally.
So we'd have to define the string in the field.
Yeah.
And snip it.
Yeah.
Within 2 minutes.
Yeah. That's if you're attacking the fiber optic line.
Yeah.
My thought when I was thinking is if you're trying to defend against these things coming at you, aside from the obvious like shoot it out of the sky, but good luck, the target is about the size of a football, right? It is traveling at 60 miles an hour. Nets are another obvious.
Well, that's just like a way to fight drones,
right? It's a way to fight drones automatically, hopefully.
Yeah.
Right. But the other one I was thinking of is honestly lasers. If you can blind the camera, if the sensors of the drone, then the operator can't see what they're doing.
Well, okay. So I mean, I think if I know the string is going to show up, and I can cut it in, and I have to cut it in the next 2 minutes, there's some version of that starts being doable. If I had a bunch of like harvesters or something with a bunch of teeth, and they quickly drove the field, depending on the size of the field, the speed of the harvesters, I could reasonably cut the line.
I mean, I think the problem with that approach is with 20 miles of fiber optic line, the very next drone you send, you knew that it got cut in this location. Yeah. You'd either target the harvester or you just go around the field.
If I had perfect optics, could I see the string coming out of the back of the drone and deduce where the station is?
Unlikely. So because the fiber optic is unspooling from the quadrotor, so it never gets tangled in a sense, right? Because if it gets wrapped around something,
but
it just unspools.
It points towards a direction, and it unspools at a speed.
Well, yeah, but think about it. If the drone's flying northward and then it corners around a tree and starts driving east, if your observation post sees it coming at that point, you'll think the operator's east when they're actually south, or west when they're actually south.
If it unspools fast enough, it'll never get taught.
Right.
And then
that's exactly what happens.
And you can't just say, oh, it's a straight line.
Right. It's not hanging in midair. It's on the ground the entire time. Yeah. So the attacking the fiber optic lines, like actually, what I've heard is
if it's on the ground the entire time, you don't actually have to cut the wire. You just need to chew it up.
Yeah, that's right. And so actually, the way people have been doing this manually is they run out they see the drone go by, they run out with a pair of scissors, and they cut the fiber optic line. But that has obvious risks.
Yeah.
Right.
Well, no, but I mean, like you have an AGV that has teethy treads,
and it just drives back and forth.
Yeah, all day, every day.
Yeah, I mean, if you can make the AGV cheaper than the drones,
yes,
then
I mean, not necessarily cheaper, but like if it's small enough and fast moving enough, it would take several drones to get it.
So what you're saying is, I like this idea. This is very Mad Max. Okay, so if I'm setting up a forward post somewhere and I want to defend against it, then 2 kilometers away from the forward post, or 1 kilometer, you set up a series of saw blades, basically. Yeah. Like roving saw blades that just spin in a circle.
But it don't have to be saw blades. If the string's going to end up on the ground.
Well, that's what I'm saying. So it's a robot with a saw blade on the front of it, a ground robot.
Yeah.
And it just
like one of those battle bots with the buzzsaw.
Yeah, that just at very high speed spins around, like you literally establish a circle or a polygon.
Yeah.
And they just continuously cover this area.
Yeah. And you can have like 20 of them, 50 of them.
Or 50 of them, right? Yeah. So what do you need to do this? You need some level of GPS.
You need like I think of this as it's GPS plus a computer.
No, it can't be GPS, because then the immediate thing they're going to put on this drone is a jammer, and then your saw blade thing will go off track.
It's something to do ground. Okay. You run a wire on the ground.
Yeah.
You do line following on that.
The metallic wire.
And just drive in your circle around it at some speed.
And it has to be set away from your defensive zone significantly, so that the wire has a time to actually hit it. Yeah.
I mean, not significantly. Probably in a range of
500 meters.
I don't know, 20 meters.
No.
If these drones are flying 5 feet off the ground, then geometry better than I do.
No, but within 20 meters, that's lethal blast radius for like practically
not a grenade.
No, but
weird books I read in high school. If you throw a grenade at someone, something like 97% of the shrapnel hits the ground, and like the effective kill radius is like a meter.
Sure, but
like grenades are really good at like making it making you not good at walking when people want to shoot you. They're not like, small neutron bombs.
No,
of
course. I mean,
I do love the movies where they throw a grenade and like the city block levels, and they're just like, yeah, well, that was a hell of a grenade.
No, but anyway, you have to offset this like
not like
buzzsaw
500
zone.
meters.
That's actually probably more even viable, because I think the thing that I was arguing with myself about the laser is the problem is actually the.
I mean, the targeting of the laser would be cool. That would be a way cooler situation.
I think.
We talked earlier about slingshots to take out drones.
Yeah.
And I think like if you had an automated,
at that point, just use a gun.
Yeah.
Come on. I think the problem with the laser is actually the Geneva Convention. If anybody's still paying attention to that. Because if you point the laser level to the ground, you're going to blind whoever's behind you. If the laser is powerful enough to burn out a sensor on a camera, it is certainly powerful enough to blind someone.
Is Geneva Convention against lasers that blind people?
You're not supposed to try to be blinding people, no.
Yeah, but you're not trying to blind people when you shoot a laser at a drone.
Not an expert in this, obviously.
Yeah,
but
like, I think
that would be a problem.
I think I'd be more concerned about the explosives going off in people's eyes. I think unsafe lasers being shot generally at drones would not trigger the Geneva Convention.
I think you're underestimating how far this laser would travel, right? Like if I have to burn out a camera optics 100 meters away, I'm blinding people 2 or 3 kilometers away easily.
Yeah.
Right.
I mean, the problem with a laser system like that is then you have to get really good at tracking and targeting.
Yeah.
Which again, if you can do that, shoot it. Like if you can track it that well, put like 20 explosive rounds in the vicinity of the drone, and if any of them go off, it will take a rotor out. The drone will come out of the sky.
Yeah.
Yes. And
no, but I like this like Mad Max spinning saw blades thing. That's actually
you
pretty
just set
ridiculous.
up a smart barrier.
Yeah.
And as soon as the wires hit the ground, you're good.
Yeah, because the wires have to hit the ground.
Yeah.
It's like they're not going to stay in midair.
Yep.
And you can make your little saw blade bots cheaper than the quad rotors.
And honestly, you could just use any road, any like dirt road as the basis for
your perimeter. Yeah. Anything that's relatively clear of vegetation.
Dig a quick trench, put the wire in.
I would actually bet it would be actually pretty hard to take out these saw blade bots with a quad rotor because they'd be traveling fast.
Well, yeah.
And tracking something with a quad rotor fast is hard.
Like the saw blades, to be clear, the saw blades are not doing anything smart.
No, yeah, they're just falling.
Just driving at 15 miles an hour, spaced every minute or so.
You know what the other challenge is going to be? To maintain this perimeter, you probably need, let's say you need 20 of these robots to actively maintain the perimeter, you actually need 40 or 60 of them so that any one of them, to actually charge one set while the other set is running, right? So, but that means you probably need to automate the system to go around the circle, and when you get low on charge, call in a replacement, go back, dock yourself. So you don't have a human constantly manning this thing.
But like, what's interesting is
as a proof of concept, that can actually work pretty well.
We live in a time where robots like that are cheap enough. Like there's nothing. Honestly, you could use a fast robotic lawnmower for the same purpose. Because the lawnmower should also cut the wire.
You honestly don't even need like a lawnmower, but I think honestly what we need is just a sharpened V-shaped blade on the front of the thing. And it's just driving, and the bottom edge of it just gently digs into the ground.
Yeah.
And if the fiber optic lines are actually very fragile.
Yeah.
People are cutting them with safety scissors. You just like they're very, very fragile. They're strong under tensile strength, but under cutting strength, it's shear immediately. So it basically be an RC car with some level of localization. And a V-shaped blade on the front of it, just driving around. You could make this thing for $200 at any relative scale.
Yeah, and actually for batteries, you can just put a couple DeWalt batteries into it, so you can hop swap them pretty easily.
Yeah, like something off the shelf. That might actually work. That's actually probably a very viable defense.
Yeah, I mean, like the plate bot that we have that has, that could do that. I don't know if it goes fast enough.
No, it doesn't. I mean, you probably want this thing going pretty fast.
Yeah.
But, because if again, there's videos of this conflict has been heavily videotaped by people with cell phones or whatever. And there's videos coming out and as fast of a drone operator as you can be, you're not going to be that fast. Right. Even the one, the attack on the airport that happened recently or on the military base, right? You can see their dwell time is pretty long.
So that attack is like a big deal in military circles.
Yeah,
Like that
it
was
should be.
it was like a Trojan horse of like some containers just open up. What's funny actually is the thing that attack reminds me of is a Russian program called like the Cargo K missile.
Yeah,
I don't know if you remember this one.
No.
So in the aughts, there was a lot of hubbub about Russia selling a ballistic missile system that could be launched from a launching system that very closely resembled a shipping container.
Okay.
And in their mock-ups
I could see problems with that.
of using this, there was like literally one of the mock-ups was a army with F-16s and blue forces were invading a country.
Yeah.
And the country had some merchant marine. And the merchant marine shipping containers opened up and launched a bunch of missiles and sunk a nondescript blue flag aircraft carrier.
Yeah.
Called the Cargo K missile.
Okay.
I believe was what the program was called. And no idea if it ever became real. Like it was a really bad computer generated mock-up sort of thing. But that is very similar from to what the Ukrainians were able to achieve, where they had shipping containers open up or grain rail cars.
It was trucks.
Yeah.
Yeah.
Open up, drones launch from them,
Yeah.
go to a strike. They also, I don't think enough people have talked about the intelligence coup of when they launched the attack.
Yeah.
Apparently, the attack happened within like 2 hours of takeoff for a major Russian strategic bombing raid over Ukraine.
Oh.
So Russia took their biggest and best bombers out of storage, out of Siberia, put them along the front with Ukraine, got them all out, filled them with fuel, put bombs in them, and we're like, we're going to go bomb the Ukrainians back to the Stone Age. And in that window, between the bombers are out and Kiev's in rubble, the attack happened.
Yeah.
Like,
I mean,
that is a lot of people fell out of a lot of tall windows over that intelligence disaster.
Well, I heard even the drivers of the trucks had no idea what they're doing. They're like normal truck drivers.
Yeah.
It's like they had no clue.
Which of course, like that'd be the easiest part of the whole thing.
Yeah.
Because the drivers, they're not gonna.
Here's a container. Like, take it here.
I'm sure many of them also fell out of windows.
Yeah.
I've seen a lot of folks want to look at drones launched from closing structures. What's confused me is why that's been so hard. Is it just the idea that the drones have to come back?
Yeah, it's mostly that.
So again, if drones become attritable.
Yeah. It's mostly like, and actually, again, like civilian sectors ahead here. Mm-hmm. Where the best guidance systems I've seen for this is actually those light shows with the quadrotors that like China puts on a lot and a lot of countries put on a lot. If you look at some videos of them coming back to land to charge, it's this like barely believable cloud that self-organizes and then lands in these little charging suitcases that you then just close the suitcase and you're done.
Yeah.
Like very, very extremely well done.
Yep.
That's fairly tricky.
Yep.
You need very good coordination. You need good localization. You need a beaconing system. You need all this stuff. But if it's literally like drone is in a box and the box opens, the drone just has to go up. And that's fairly straightforward.
Yeah.
Failure rate there is low, so that part's not hard.
Huh. Yeah, and yet it's the strategic air defense of the whole world just was like,
This is a big problem. I guess
maybe they buy some robots to drive in a perpetual loop.
They need some saw blades. if this gets developed and we get in trouble.
This is one of those podcasts where it's like, are people going to show up in a black van?
But can I just clarify? This was entirely Stefan's idea.
Farcical. It's entirely a farcical. The real problem with this idea is that saw blades don't exist. And one day, that was science fiction. There's no such thing. You cannot cut fiber outlines.
Yeah. Oh, this is like dangerously close to a real idea. All right.
I think you're passed over that line. With that note, Ilia, what are we going to talk about next week? What more war crimes that we can invent live on the air?
God. Hopefully a less defense-oriented discussion next week.
Yeah, back to philosophy.
Yeah, exactly. Yeah, this is a wild ride of a show. We went from like humanity benefiting robots to saw blades on cars. Yeah.
And with that, thanks so much for joining us. As crazy as this one was.
See you next time.